All right, so for the last few that we're going to do a couple of work problems, and then we're going to do a couple of find the angle problems and stuff like that. So one of the things that we have is your basic formula for work is going to be the force, which is your magnitude of force, times the distance, okay? So my distance in this case is going to be AB. And this is just basic, I'm shoving stuff along a sidewalk or whatever. So if I want to find the work done by a force of 5 pounds, so I'm told that, my force is 5 pounds. I'm at 30 degrees, okay? And I am moving something from 9 feet, from 0, 0 to 9, 0. So I'm moving something from 0, 0 to 9, 0. Okay, so this is going to inform our force, and then this is going to inform our vector, because I can't even think straight anymore. All right, so work is this mess. So I need to find this first. And I can rewrite this also as W equals the dot product of force times my vector. So what I have is, I know that my magnitude is 5. I know that I've got the cosine of 30 on I plus the sine of 30 on J. Okay, so that's going to be my force. Now, what I also know is that this vector is going to be initial minus terminal, because I'm starting here and ending there. So that's going to be 9 minus 0 is 9i. So I have this thing. And then I've got 9i plus 0j, because I just want to shove it along the floor. Okay. So I need to clean this one up first, and then I can do a dot product. So 5 times the cosine of 30 is going to be 5 root 3 over 2 on I. And then 5 times the sine 30 is going to be 5 halves on J. So I've got that vector, and then the dot product to this vector plus 0j. So these two are going to go to 45 root 3 over 2. And remember, a dot product is an answer. It's a number. It's not a vector. So drop your components, your horizontal component, your vertical component, and then 5 halves times 0, 0. So I end up with, this is how many foot-pounds of force, or how much work is done. Sorry, that is how much work is done. Can you tell I've never had physics? All right, so let's do another one. I have a car on a hill, and I'm trying to keep it stationary. So that is supposed to be vertical, sorry. All right, so I've got a car, and I do know that it's parked on a 5-degree incline. So here's my little car. Look at him go. There's his trunk. Okay, so I'm trying to keep it from rolling down. I do also know that the weight is 4,900 pounds. So if you think about that, I'm dropping down because of gravity, 4,900 pounds. So that's going to be 4,900J, okay? But we're going to approach this a different way. So I do know that if this is my hill, okay, so I'm just going to do a little sketch over here. And I'm just going to continue my hill out this way. So my hill's going to come up this way. And what I want to do is find something perpendicular to it. So what we're going to do is create another triangle. What's going to be helpful is if I can make the hypotenuse 4,900 instead of the vertical component 4,900. So that being said, what I'm going to do is take this right here, and I'm going to redraw it this way. Okay, so notice that I've made a 45-degree angle to the incline. And so what do I know? I know if this was 5, that this was 85, correct? So if this is 85, and if this is a right angle, then this must be 5. Okay? So now what I've done is I've created a triangle, and notice it's just parallel, okay? I've created a triangle whose vertical or whose hypotenuse is my 4,900, okay? So if I want to find the work done, I want to find this vector right here, or I want to find the work done. So all I need to do is find the sine of that angle. So the sine of 5 degrees equals opposite, which is what I'm looking for, okay? So it's going to be V for Van over hypotenuse. So that gives me 4,900 times the sine of 5. So when I do 4,900 times the sine of 5, I find out that the force needed is 427.0 or 0.1 pounds. For 427.1 pounds of force. And now I want to turn around and I want to find, I'm doing a decomposition, was what I'm doing. That's the force required to keep the vehicle from rolling down the hill. So I just found this side of the triangle. And now I want to find the magnitude of the force perpendicular to the hill. So you'll notice that this is perpendicular to the hill. So I just need to do cosine of that angle. So the cosine of 5 is going to be perpendicular to the hill over my 4,900. So 4,900 times the cosine of 5 is going to be that perpendicular force. So 4,900 cosine 5 gives me 4,880, what? 4,881.4. 4,881.4 pounds. Okay, so that means you can do another one. And then our final one is we're going to actually set up 2 different ones. Sorry, I've got 20 million notes over here to make sure I cover everything. So, actually, let's do another word problem like that just because my picture was kind of ugly. So here we go. We've got Timmy and Larry, and they're going pushing a piano. They did not organize well, and so the piano is on the ramp. So here's the piano that I'm not going to bother drawing, okay? And then here's Timmy trying to keep it from rolling down, okay? So what we know is that this ramp makes a 20-degree angle with the ground. And I do know that this force right here is 270. Okay, so I can apply the same thing. I actually want the force to not be the vertical component. I want it to be the hypotenuse. Okay, so I am going to turn this thing and so drop this down so that he is a perpendicular line. So if this was 20, this was 80, which means this is 20. So I can now find that my hypotenuse is 270. So the sine of 20 degrees is piano over hypotenuse. So 270 times the sine of 20. 270 times the sine of 20 gives me 92.3. So 92.3 pounds of force. There you go. I don't know if you saw any of that. Look at my pretty picture with Timmy. All right, so I'm given 2 vectors. I have a vector. Vector u is given as I plus 4j. And I'm given vector v. And vector v is 5i plus yj. It's what? 5i plus yj. Look, there's a variable. Okay? I want to find a vertical component for v so that the angle between these 2 vectors is 30 degrees. So the angle between the 2 vectors is 30 degrees. And once again, I have lost my notes. Hang on. I may have to pause you if I cannot find them rapidly. Where are my notes that I typed up for you so pretty? Hang on. I'm bitter and angry. It was underneath my spiral. All right, so I have to find how do I calculate the angle between two vectors? I'm going to use the cosine of theta equals the dot product divided by the product of their magnitudes. So here's what I've got. The cosine of theta will equal their dot product divided by the product of their magnitudes. Okay, so in this case, I want to ensure that the angle between these things is 30 degrees. So I've got the cosine of 30 degrees equals their dot product, which is going to return a constant. So 5 times 1 is 5, plus 4 times y is 4y, divided by the product of their magnitudes. So I've got the square root times the square root. So this one is 1 squared plus 4 squared times, and this one is 5 squared plus y squared. Okay, so I happen to know what the cosine of 30 degrees is. It's root 3 over 2. So I have root 3 over 2 equals 5 plus 4y over, and remember I can slap that underneath a common radical. If I'm multiplying radicals, it's probably not the best way to put it. But 1 squared plus 4 squared is 17. So I end up with 17 times 5 squared. Let me write this down. I have root 17 times 25 plus y squared. So I can put that root together, which I'm going to do it in a second, not quite yet, because I got another root over here and I'm fixing to cross multiply. So I have, this is root 17, and this is root 25 plus y squared. And now I can cross multiply and I can solve for y. So this gives me root 51. Once again, I probably ran out of space. Times root 25 plus y squared equals 2 times this, which is going to be 10 plus 8y. And then I'm going to square both sides so I can get all this crap out from underneath the radical. So when I square this side, I'm going to end up with 51 times 25 plus y squared. And when I square this side, I'm going to end up with 100 plus 160y plus 64y squared. Okay, so distribute, well, I'm distributing, 51 times 25 is something large. 51 times 25 is 1275. So I get 1275 plus 51y squared equals 64y squared plus 160y plus 100. And now I'm going to combine like terms. So I'm going to subtract 51y squared, subtract 51y squared, and subtract 1275, subtract 1275. So what I end up with, and I'm going to go up here so I can see what I'm doing. Okay, so you see that, now I got to see it. So I have, sorry, that's my little thing from last time. I have 64 minus 51 is 13y squareds. And then plus 160y. And then 1275 and 100 gives me a negative 1175. Negative 1175 is 0. And so for sake of time, I'm going to tell you to, well, let me see if everything's divisible by 13, which I'm pretty dang sure it's not. Are you divisible by 13? No, you're not. Okay, so we need to use quadratic formula. So I was just going to say for sake of time, but we'll just finish it out. So 13y squared plus 160y. So 13y squared plus 160y minus 1175 is 0. So I'm going to use quadratic formula. Now, back up the truck for a second. Because you squared here, remember anytime that you're dealing with radical equations and you've got a square to get rid of that radical, you had better check your answer. Okay, so I better check my answer. So knowing that, I've got negative b, so negative 160 plus or minus the square root of 160 squared minus 4 times a times c all over 2 times a. So that's what my y is going to be. Okay, going from there, let me see how specific we need to be here. 3 decimal places. Okay, so I've got negative 160 plus the square root of 160 squared minus 4 times 13 times negative 1175. And I get that answer, and I divide it by 26, and I get 5.17. And what exactly am I doing? 3 decimal places. 5.171. So y can be approximately 5, what did I just say? 171. Okay. Or I need to change this to subtraction, which I'm too lazy to type in all over again. So look at that, and then divide by negative 20, or sorry, by positive 26, and I get negative 17,479. So negative 17,479. So what you need to do, and I'm going to leave you for that, you got 2 answers, and you need to check them in your original problem. Okay? So check them in your original problem to make sure that these 2 things will produce, which actually you can do it over here, okay, if that makes you happy. Make sure that when you check those answers that the left side and the right side check out, because one of them is not going to work, so it's extraneous. All right, so the final one, you want to find an x value so that u and v are orthogonal, okay? So we're going to set up this same thing. So what I have is given vector u, I said set up the same thing, and it's not even the same problem. 2xi plus 5 on j. And then v is going to be, what is it? xi minus 4j. And I want to find x so that u and v are orthogonal. I want to find x so that u and v are orthogonal. Well, remember, for orthogonality, or for them to be perpendicular, their dot product must be 0. So I'm going to take their dot product, set it equal to 0, and solve. So 2x times x is 2x squared. 5 times negative 4 is negative 20, and I need that dot product to be 0. So I'm going to add 20 to both sides. I'm going to divide both sides by 2, and I'm going to take a positive and a negative root. So those are my 2 values that I can use for x. And that is that for that section.